और बहुत टाइम से इधर ही बैठ रहे थे हम।
हमने देखा तो उधर बैठते थे
उधर
अच्छा
उधर से ना
उधर से
तिकडे पण भेटते
क्या लेकिन सर
तो अकेले भी बैठी है क्योंकि अकेले का नहीं मतलब तो आगे जाके भी बैठ सकती है हाँ ना फर्स्ट में रहती है क्यों सेकंड में नहीं करता है ना तू क्या होमवर्क खाई नहीं पापा लग रहा है होमवर्क खा नहीं ये कुछ भी बोलती है और इंसान को टेंशन में डालती है तो क्यों बेटा इंसान को ऑलरेडी टेंशन में रहना चाहिए तू क्यों आई बोला नहीं ना तू क्यों आई भाई तेरे लिए मैं आई हाँ मेरे पास ऑप्शन हो तो मैं वही मैं मेरे ऑप्शन में तो नहीं आती बस आ भी और मेरी मम्मा घर पे घर का घर के बढ़ा के दरवाजा बंद करती है वैसे तू बड़ी बोलने वाली थी मेरा वाला तो वापस वो भी एक अगर हम यहाँ पे आके एक सेकंड दो क्लासेस का अगर हुआ नहीं हुआ तो सुन बढ़िया मत चलता हो तो ठीक है फॉलो कर दूंगी अबे हुआ तो होना चाहिए हुआ तो मैं नहीं कर फॉलो करना देखो उसकी स्टोरी दिखती रहती है हुआ कैसे होगा एकदम कर दे चला सकते हैं हाँ चल सकते हैं क्या भाई एक सेकंड सुनो अगर दो क्लास का साथ में रहना चाहते ना दूसरी क्लास का रहने लेंगे ब्रेक में भाग लेंगे दिखता है उधर से सीधा पता किसने बोला था तू नहीं जेलस का बोला था कि तुम्हारे बैठी थी वहां पे वेट कर रही थी एंड उसको मैंने सारी बातें सुनाई वो बोल रही थी तुम लोग ये बात कर रहे थे ना
everyone is it ready still you all are here continue
नहीं हम लास्ट तक देखना कर रहे थे
What is the strength of this class?
I think
9?
10.
Count.
Ritika Anura. और जय
10, huh? So 2 are missing. ठीक. Somebody tell me, where did we stop in the last lecture? Many of you were not present in the last lecture. Who was present in the last lecture? Where did we stop? I think you were writing test or something? School test?
Yeah.
School test. And last class was cancelled, I think. Okay. Where did we stop?
You were explaining the no stepping out of the boat.
Newton's third law?
Every action has
Okay, so that means the chapter is over. We have to do numericals today. That's what it is.
Law of conservation.
Yeah. One second. Law of conservation of momentum is not in the new book. Is it taught in your school?
Sir, law of conservation.
Of momentum? It's not in the new book. Come.
But there are questions based.
But there are questions, yes.
Yeah.
So that is the
Sir, maybe we taught it.
goof up. No, this is what the goof up they have done. They have removed it from the main text. So in textbook, in the new textbook, you won't get this topic.
So she taught us that in law of conservation.
Anybody has the new textbook?
No.
Not brought. Okay. So I will teach it. Okay. And then
Conservation of momentum. Conservation of
dot. Okay, so we'll do it. Not a very big topic, so let's do it. But in the new textbook, it is not there. Let's take it. So let's do it. Right, so conservation of
very jolly.
what is the date today?
26.
July. 2020. Now this is a very scary date. On this day, many years ago, Mumbai was flooded. Have you heard about it?
Yes, sir.
You were there. You were there.
No, sir, I was Sir, I was stuck somewhere. I did not come to
Same here. I was on the road somewhere between Chembur and Ghatko. All night in the bus. Sat in the bus for protection. We walked.
in the opposite.
I sat in the office, but when we left office, thinking that we'll get something, somehow we'll reach home, but no commute available. So we walked and walked and walked, and then in the night, we took a bus, took a ticket of last station, and the bus did not move. We entered the bus and stayed there whole night. Okay, that's what it is. Okay, so what is the meaning of conservation?
Sir, conserving something.
Conserving means something which does not change. Okay, that's the meaning. Okay, we started the class. Okay, so what is the meaning of conservation? Remains same. Conserved means remains same. So what remains same? Momentum. So what we are studying is law of conservation of momentum, right?
Sir, can you?
Which time? You don't need?
No.
So what it means is, let's say take any incident or event, for example, say accident. Let us say you have two bodies. Okay, you have one body and another body. Let's say its mass is m1 and its mass is m2. These are the two bodies. The first body is traveling with velocity u1, second with u2, right? And this body is moving fast. Let's say u1 is greater than u2. What will happen? After some time it will collide, right? इससे टकरा जाएगी. So the event when the body collides with the smaller body, what happens during collision? What will happen? There will be a force. There will be impact. In collision, what will happen? There will be impact. So first body will apply force on second body, and by third law, second body will apply force on first body. So at the point of impact, there will be force by first body on second body, and equal and opposite force on first body by second body. So these two forces will act. Okay? Right away.
Why is it said that the object will, because sir, it says
Question.
sir, if we apply a force, the opposite equal and opposite force is applied by that body, but the mass of the body is greater.
So what?
Sir, then it should apply more force.
Effect is different. No, it won't. The same force will be applied, right, during the interaction, but the effect on each other will be different in terms of acceleration. So this will accelerate.
Sir, but why it will be different?
That's how it is. That's nature. Isn't it? Let's say this wall is there, okay? There is a plaster of Paris. And you thought, okay, let me hit it. And you bang your head on the wall. Okay? Who will get more effect, you or the wall? You will get it. People will see that you are affected badly, maybe bleeding also. Will anything happen to wall?
No, sir.
Maybe some little bit of crack in the POP.
It'll get stained.
it will get stained with the blood. But blood oozes out little after. Nothing happens to bone. Maybe a little crack in the PO. Okay? Same force which hit your head made you bleed. But the wall remains as it is with little bit of crack. That's it. So that means to damage the wall, you need much larger force. Maybe some explosion or something like that. Then the blow.
Sir, but the force applied will be the same.
Yes. No. Looks explosive will be more force. No?
Sir, but if we apply force, the equivalent opposite.
So I am telling you, okay? You believe me.
Yes.
Because right now you are not able to gather it. So I am telling you the forces will be same. Now let's go forward. Huh? So as you grow in higher classes, the same thing you will understand. You will understand it differently. So you need to.
So I think she missed the class very extended.
Is it? So maybe. In one class you are absent, right?
Sir, I heard it in my school.
So you maybe. So, but I think you were not present in my class.
Yes, sir.
Some gap is
You
there.
in the class where you explained this example.
This and then she was not. So there is a gap. So now you understand that there is a exchange of force between each other at the time of collision. So this is the collision happening. Okay, why is the collision happening? Because this body was traveling faster than this. Now after collision, what happens? For the first body, force is opposing its motion. It is against the motion. So it will retard. For the second body, the force is in the same direction as the motion of the body. So this body will accelerate. Got it? So now, the speeds will change after collision. This will move with say V1 and this will move with V2. Okay, so this is happening. Right. Now what this law says is, this law says conservation of momentum. So what was the total initial momentum of these two bodies? So total initial momentum Pi is equal to m1u1 plus momentum of this m2u2. Okay, and what is the total final momentum? Momentum symbol is P, F for final. Total final is m1v1 plus m2v2. Okay, so what the law says is that initial and final momentum will be same. This is what is the law. Okay, so by law of conservation of momentum, sometimes it is called linear momentum because the bodies are traveling in straight line. Linear momentum. Total initial momentum is equal to total final momentum, provided there is no other force acting on it. Collision में जो भी force लग रहा है only because of these two bodies. बाहर से there is no other force acting on these two bodies. Is it clear?
Sir, friction force must be there.
No. So we are ignoring all this. So while studying, we will ignore so many forces. So only force acting is this collision force. Okay, all other forces we have not considered. Okay. Now, so we can prove it. So how do we prove it? So by third law, by Newton's third law, during collision, F21 must be equal to F12 and it should have opposite direction. Yeah? We have read about it by Newton's third law. F21 is equal to minus F12. Now what is F21? Force applied by second body on the first body. So this is the force on the first body. So now applied by Newton's second law, what is F21? F21 is mass of first body divided by acceleration produced in the first body, right? Isn't it? So what is it? So mass of first body is m1, and what is the acceleration? V1 minus U1 upon T. What is the acceleration produced in the first body? V1 minus U1 upon T. Okay. And this is equal to minus M2. Now this is the acceleration produced in the second. Force is mass of second body into acceleration produced in the second body. So time of collision will be same. Let us say they collide for this duration. This is the time of collision. It is common for both the bodies. Okay? How do we get this step? By second law. By second law, what do we get? F is equal to ma, which is equal to m v minus u by t. This is what is we get by second law. And it's all right. So now t gets cancelled. Simplify it. So what do you get? You get so m1 v1 minus m1 u1 equal to minus m2 v2 plus m2. Okay. So now we'll rearrange. M2 v2 will come here and m1 u1 will go there. So what will we do? So therefore m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. So we got it. What is it? Total final momentum. And this is total initial moment. Right? So we got the law. So after this, so therefore we get EF is equal to E. Proved. So the law of conservation of momentum is proved. So you can write, see the statement in your volume. What's the statement? That's the mathematical proof of that. Hmm? Okay. If you're done writing, just let me know. I'll give you the statement. written? Three of you still right. Completed. Okay, write down. During collision of two objects, during collision of two objects, the sum of their initial momentum is equal to the sum of their final momentums.
So could you repeat after initial momentum?
What have you written?
The sum of the initial momentum
Is equal to the sum of their final momentums. Okay. Sum of their final momentums. This is called law of conservation of momentum. Okay. This is the law of provided there is no external force acting on it. Provided there is no external, you can say unbalanced force acting on them. The words could be little here and there, you can verify it from textbook or knowledge. What have you written? One person read it. Did you write it completely?
Yes.
Read it.
During collision of two objects, the sum of their initial momentum is equal to the sum of their final momentums. This is called the law of conservation of momentum, provided there is no external unbalanced force acting on it.
Yes, on them. Acting on them. So the only force acting is to do the collision. No other external force is acting on the body. Okay. So this is law of conservation of momentum. So what do we do with this? So there are so many illustrations given in your volume. You can see the volume to demonstrate the law of conservation of momentum. Right. So this is combination of law of conservation of. How did you derive it? You derive it by combining third law and second law. So these illustrations will show examples of third law.
Sir, derivation there in our question.
Huh?
Sir, is this derivation there in our
I don't know. You ask me to. If your teacher, because there are some questions in the book, in back exercise, even in the new book. So, but it's simple. What you have to remember is, in any situation, this equation you have to remember. Just have to remember this equation. Okay, there may be questions based on this formula.
Yes, sir, there is.
Okay, so just remember this. Right? So what is happening is now, look here. So how to solve, where to apply this kind of a law, this law. Let's say you have a balloon, okay? Balloon is filled with air, look here. And you have stick to it a straw, a hollow straw, through which a thread is passing. So that straw, through the straw, the thread is passing between the wall. So balloon is hanging over there. Now when you untie its mouth, so air will gush out of balloon, right? The air gushes out. So because of that, whatever thrust, the forward force it goes by reaction. So like when the wind is going in this direction, so an opposite force also will be exerted on the balloon. So balloon will move forward. You will see the moment the air comes out, it will move forward. Okay? You can try this at home. Whereas in this case, you have a test tube filled with some liquid, okay? And now you fitted a cork. You close the mouth. So when you heat the liquid, it will turn into vapor. Then the vapor pressure will increase. Due to that, the cork will open. Imagine a pressure cooker. Sometimes the whistle, what do you have? It comes out, right? So it comes out due to excess pressure inside the cooker. So if the moment this cork comes out with force in the forward direction, it will exert a reactive force on the test tube in the reverse direction. So both will go like this. Okay. So in this situation, when you have to calculate, like mass will be given. So these are two objects, cork and test tube. So mass of cork, mass of test tube, and velocity of test cork is given. Then you may be asked to find what is the recoil velocity of the test tube. With what velocity it will go behind. Okay. In such situation, you have to make use of this. Here also, there is a gun and there is a bullet. So two objects, gun and bullet. So bullet mass, gun mass will be given to you. Initially, gun is also at rest, bullet is also at rest. So total initial momentum will be 0 in the first case. Because U1 and U2 both are 0. But when the gun is fired and the bullet comes out, then it will make the gun recoil backwards. So sometimes the question will be asked, find out the velocity with which the gun is recoiled.
Yes, sir.
So bullet velocity is known. That is its final velocity. And gun velocity you are asked to find out. And then equate it to 0. Because initial momentum was 0. But the final momentum is not. Okay. So it is not only collision. This time it is explosion. Okay. Situation may change. So you will know when the question is asked. You will automatically, you will have, it is already on.
Could we turn it off?
Huh?
Could we turn it off?
Turn it off. Somebody stand up and do it. Remote hai kya? Remote nahi hai. Stand on the bench and do it. Yes. More easy.
Yay.
So we got full control. Dunya hamare batti. Okay. All right. Shall we take up some questions now? So, yeah, go ahead. Sure, we'll solve the numericals now. So, somebody give me the. So there are NCERT solved questions and then there are questions at the back of the book, right?
There are many of them.
There's so many of them. So what should we do? Shall I do the NCERT questions? Okay, let's do the NCERT question because in your schools mostly they will ask that, right? And if you are able to do NCERT question, you should be able to do it. Okay, because NCERT questions are slightly tougher.
Yes, sir.
Okay, so let's do the NCERT. Although it is solved, but what I do, the steps might be different and simpler. All right, so start with in text question. If action is always equal to reaction, explain how a horse can pull a cart. Which question is this? In-text question of your textbook is actually question number 6 in your volume. Okay.
It's 5. So
Ah, 5.
here,
Okay.
the horse is not pulling the cart. It is showing force on the ground, no?
Yes.
To take it back.
So that's why they have asked you this question to confuse. Right? देखो क्या होता है? Is this question discussed in your school?
Yes, sir.
It's a very popular question. So horse and cart problem. So this is question 5 in your UT volume. And it is a question from your textbook. Okay. So when you have a horse, okay, so he is actually applying pressure on the ground. I hope this is looking like a horse.
Is it really a horse?
Whatever.
It will have a tail.
This is a cart, okay? So the cart, it's looking like a donkey, right?
Like dinosaur and lizard.
Okay, don't miss the point. The point is, so the horse, and this is the cart, right? When horse is pulling the cart, then cart also should pull the horse. That's the logic, right?
Yes.
Yeah. But the thing is, these should be treated as one object now.
Why?
Because they are connected bodies, they are not separate. It's not that the cart came and banged the horse. No, it's not something like that. It's connected, right? So this is actually one system. These are not two systems. Okay. So now what is happening is, the horse is applying force on the ground. Okay, this is the road. Horse is applying force on the ground. And therefore, by reaction, the road or the ground will also exert force on horse. So horse will experience reactive force in the forward direction, same line. So what basically horse is trying to do is trying to push the road
Sir, is it
backward.
not frictional force?
Sorry,
Sir, is it not frictional force? Because if it's
it is the frictional force only. Okay, this force.
Sir, but the horse must not be able to do that because
If there is no friction, they will slip. Is it slipping? So it's a combination of things. What you need to understand is, when horse, how do you walk? One is the surface should not be slippery. So there should be friction also. That's the first requirement.
yes.
Then what do? You're trying to push earth. But what earth does? Tosses you up. So that's how you're walking forward. So it's a combination of things, not just one thing.
Yes.
Okay? Is it understood? So why the horse is able to pull the cart is due to the reaction from the ground. That's the answer.
The force the horse is applying on the ground, the same force is acting on it.
Yeah, the same force by Newton's third law.
Sir, but why is the horse able to move as the cart's mass is still bigger? Means, sir, if its mass is bigger, then, sir, even if the applied forces means it will be able to overcome the means force of the horse. No?
Vinny, this is connected, na? This is connected body. It's not that this is slipping. It's not slipping. It's tight.
Yes.
Understand? So the net force of the Earth's reaction is in the forward direction. See, its weight is downward, horse weight is downward, right? Then the normal reaction will act over here on the horse also here also. There is no motion up and down. It's only the forward direction.
Okay.
So you need unbalanced force in the forward direction.
Okay.
Okay? So the unbalanced force acts on the same body. See, basically for motion, what do you require? You require unbalanced force. Okay? So unbalanced force is this. Action reaction is not an unbalanced force. Here it is action reaction.
Yes, sir.
Okay? But for motion you need unbalanced force. So the unbalanced force is provided by reaction from the ground.
Okay, sir.
You understood? Then the motion takes place. So horse moves forward. Due to reaction from the ground. If you take this also, action and reaction. So action and reaction are acting on different bodies. So their effects will be on different bodies. For motion, that is not responsible.
Okay, sir.
Okay. For motion, only unbalanced force is responsible. So this is unbalanced, which is ठीक है अब समझ जाओ जो भी है समझ में आ गया read the answer see if you understand it answer is given the same thing is given action and reaction act on two different bodies they are not balancing forces the cart is pushed ahead due to the reaction from the ground which is the unbalanced force okay next question explain why it is difficult for a fireman to hold a hose which ejects large amount of water at a high velocity which law will act here
Third law.
third law yes third law right so from the hose let us say this is a hose water comes with lot of force in this direction force on water so by third law there will be reaction on the pipe the force with which the water leaves pipe the same force is exerted on the pipe by the exiting water so that's why the firefighter will experience a force same thing like revolver example in the last class same thing okay so that's reaction so all the answers are given we'll just discuss and move ahead so is the reaction on the horse okay next question what is the next question from a rifle of mass 4 kg a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second calculate the initial recoil velocity of the rifle we just discussed it how will we solve it these two questions any doubt is there understood right straightforward now this question what is given I've taken your volume what is given you have a rifle of mass 4 kg mass of rifle is 4 kg then what is given mass of bullet is 50 gram which is 0.05 kg. These two are given. Initial velocity of bullet is given as, initial velocity symbol is U. So you take UB, this is equal to 35 meter per second. And what is initial velocity of gun or rifle? Zero. Yeah, because it is stationary. Okay. Then mass of rifle is given. You have to find what is the recoil velocity of the gun. So let's call this as V rifle equal to what? The final velocity. Okay. So which formula? Calculate the initial recoil velocity of the gun.
Sir, but for that we should also know final velocity of the.
अरे वो वही इनिशियल रिकॉइल नहीं है, रिकॉइल एक ही बार होता है, वो फाइनल वेलोसिटी ऑफ द गन. इनिशियल तो जीरो ही है ना.
हाँ सर.
वही इट मींस दिस वन. ओके, इट मींस फाइनल वेलोसिटी ऑफ द. जब बुलेट बाहर आएगी तभी तो गन पीछे जाएगा, उसके पहले तो बुलेट और गन दोनों जीरो जीरो है. ये भी एक्चुअली वीबी लेना चाहिए अपने को, क्योंकि यू भी तो जीरो ही है. ठीक है, ऐसा होगा. और ये वी आर निकलता है, वी राइफल भी जीरो है. सॉरी, यू राइफल इज जीरो, यू आर, वी आर निकलता. ठीक है, तो इनिशियल को यू रखो, फाइनल को वी रखो. थोड़ा कंफ्यूजिंग हो गया नहीं?
Sir, now we can apply.
नाउ इज इट ओके? और इसको लास्ट में लिख दो अगर तुम कंफ्यूज हो. ऐसे लिख दो उसको, वी आर इज इक्वल टू व्हाट. नाउ इज इट ओके? सो व्हाट इज law of conservation of momentum? So by law of conservation of momentum,
Sir, mr into vr plus mv.
कौन लिख दिया? law of conservation of momentum. हाँ, yes, mb ub plus mr ur must be equal to. So what is the law? P initial must be equal to P final, right? तो P फाइनल क्या हो जाएगा? MB BB प्लस MR BR, यही होगा. ठीक है ना? यही है ना?
Yes sir.
मुझे कुछ ठीक नहीं लग रहा है तुम्हारा. यही है ना?
हाँ.
तो करो इसको. क्या हो गया कि UB जीरो है, ये भी जीरो हो जाएगा, जीरो जीरो होगा ये पूरा. ठीक है ना? UB UR दोनों का जीरो है इनिशियली. और MB क्या है? 0.05. BB कितना है? 35 प्लस MR कितना था? 4. BR अब यही निकालना है आपको. So therefore 4VR is equal to minus 0.05 to 35. Therefore VR is equal to minus 0.05 into 35 divided by 4. ये आ जाएगा. निकाल लो इसको. कितने टाइम जाएगा? 4 8 जा 32, 4 8 जा 32, 3 4 7 जा 28, 4 5 जा ऐसे हो जाएगा. So find out how much is this. So 5 5 is 25, 2 5 is 35 plus 2 47, 0 43. कितना आ रहा है मीटर पर सेकंड? और ये negative, opposite direction में. Negative sign means gun will recoil in the direction opposite to bullet. Okay. So this will be 0.48 minus 0.48 meter per second. ठीक है? Means if bullet goes ahead, gun will recoil in opposite direction. What's so funny? Anything funny? You did not understand it?
No, I understand. I'm just looking at the horse.
While I'm explaining this.
Let's just look at the horse for a second. And then
This is not a horse.
it's a lizard kind of.
Let's make it a horse.
No, it's a little bit of mouse also.
How is the ear of horse? Up or down? ठीक है यार चलो ये समझ में आया?
Yeah.
Is the answer correct?
It's minus 0.44 meter.
हाँ 44 sorry. 3 को मैंने 8 लिख दिया. See anything? 7 when you round it off it should be 4 right? This is 3 right? So it will be
Yes, sir.
good.
What if you don't round it off and write 4 answers?
That's okay. That's fine. That's fine. Just gives an impression you're a bit lazy.
No, it means most of the
Technically
times-
nothing happens, but ideally you should keep it to 2 decimal places. That's fine. Okay, next question. Are we good till here, everybody? Huh? Everyone is with me. Okay, good. Next question, क्या है? So somebody has to read and then we'll do it. Chalo, we'll take turns. What is the next question? Read.
So two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second respectively. They collide and after the collision, the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object.
Which formula? Same formula. Yeah. So find out. So this is M1 U1 plus since is equal to M1 V1 plus M2 V2. You have to find V2. So what it will be? Therefore, V2 is equal to M1 U1 plus M2 U2 minus M1 V1 divided by M2. Substitute. See if you get the answer. So do proper conversion. Convert everything in SI. So what is the object weight, the mass? So here we can take M1 common, M1 U1 minus third. This This is my way of calculating. You can directly substitute and simplify. Plus U2 as I have. What is M1? M1 is 100 by 200. इसको kg में convert करने की जरूरत नहीं because it will get cancelled ultimately. So here we will have 1 by 2. U1 is 2 and 1. 2 minus. U1 is 2 megaparsecond. क्या निकालना है? Velocity of the second object after collision is v2, right? 2 and 1. And v1 was 1.67. Yeah. Okay. So this was plus 2 minus 0.825. This is how much? 6. Is this the answer? 1.165?
Yes.
Yes, sir.
So basically I wrote the formula, I rearranged everything and then I substituted the values in that. Okay. So whichever you find better you do it. Volume का ठीक लग रहा है तो वो करो. मैंने ऐसे कर दिया simplification.
So can we turn on the fan?
So, can you explain it after the fourth last step?
This is okay? This?
Yes.
This is okay. So what is M1, M2? 100 gram and 200
How
gram.
did you get 1 minus 0.835?
So I will be left with 1 by 2 here. I did not convert it into kg because ultimately everything gets cancelled. Okay, so I will be getting 1 by 2 only. Now this 2 gets multiplied. So 2 by 2 is 1 and this by 2 is this.
If you just cut, like, divide.
Yeah, I will divide now. 1 by 2 into 2
Yeah.
minus 1 by 2 into this.
And
Okay. Got it?
Yes, sir.
Okay. So this is what it is. Next question is interesting. So next class also we'll be doing this numericals only. Okay. Yeah. Nine. Okay. So next question. लिख लिया सबने? Finally, the horse is put to rest. All right. Chalo, who will read the next question and the last one maybe for today? Very quiet girl.
An object experiences a
इसको बोला था पढ़. पहले.
An object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the condition that must be placed on the magnitude and direction of the velocity. If no, provide the reason.
Yes. कौन बताए? नेट जीरो एक्सटर्नल अनबैलेंस फोर्स में मोशन पॉसिबल है क्या?
Non-zero velocity.
Net zero external and
क्वेश्चन नहीं
balance
समझा
force.
इसका मतलब तुम्हें चैप्टर में नहीं समझा.
Sir, net zero external unbalanced force.
Everybody read question twice. In your mind, your voice
Sir, how
should
is
not
it
come out.
possible?
Shout in your brains. Read it.
Sir, net zero external unbalanced force.
That's what the question is about. You think where it is possible, if at all. What is the situation?
So what is net zero external unbalanced force exactly? So how net
So net zero was balanced हो गया.
हाँ.
Net zero unbalanced force means unbalanced force is
There
zero.
is no unbalanced force.
Yeah, no unbalanced force. Exactly.
अच्छा.
Play of words. It's just a play of words.
There
Huh?
is no unbalanced. वो चुपचाप जा रहा है.
There is no
This is going.
unbalance.
It's nothing.
So that means what?
अच्छा हाँ.
I gave you an example. This is the example of
Non-zero
no.
velocity it can have.
It can have, of course.
But
What
it
is
is-
possible?
It is not having any force, so how is it moving?
It is not
First law of
having.
motion.
It is not having any unbalanced force.
First law of motion.
Sir, I went somewhere else.
Where did you go?
Sir, gravity affection.
Go ahead. Go ahead. I'm here. I've become very patient. Where did you go?
Like I was thinking about
When you
gravity.
do
Like
Net unbalanced force zero. Understood, right? This situation. What is this situation?
and then
She is not interested at all. Yes. What is this situation?
so that is the balance.
this is balance.
Zero unbalance means balance.
Yes, sir.
Okay.
This is balance.
Zero unbalance means balance. Unbalance is zero.
Unbalanced.
It is balanced.
How? हाँ. Unbalanced zero नहीं होता है ना?
Unbalanced zero means balance.
अगर balance है तो balance होगा. नहीं.
नहीं होता है.
नहीं समझ.
That's why I said okay. Unbalanced zero means it is balance.
The glance. See, even above you wrote unbalanced.
Okay, means balance force acting on the body. Means what does it mean? Net force
Is
is
zero.
zero. Yes. So सीधे भी बोल सकता था. यही तो प्रॉब्लम है.
It is going from balanced force.
हाँ, ऐसे की बजाय ऐसे 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 पकड़. That's what is riddle. ठीक है? So net force is zero. So now you give me the example. So is it possible for the body to move when the net force is zero? Yes.
Yes.
ठीक है? Yes. No.
Net force.
Sir, when it is
हाँ, yes, it can be. Yes.
External force is equal to frictional force. So then it is moving with constant velocity, uniform motion. Right now. So it is possible. It is possible when body moves with uniform velocity. Okay, so it was basically a case of uniform motion. That's it. ठीक है? just a play of words. So that's why you need to practice more in this chapter and the previous chapter. Chalo, I'll see you in the next class. Thank you.
हो गया था पूरा और उसके बाद
नहीं सर ने बोला ना नया सिस्टम स्टार्ट आ रही है आगे उठाएंगे मेरे को
पीछे शीट बहुत बड़ी होती है पर पीछे
नहीं इस क्लास में नहीं है पढ़ी
नहीं यार बड़ी है शीट उधर
नहीं
मैं एमबीपीएस में लास्ट पेज में
एमबीपीएस वाले
तो है ही उस पे
हाँ
मैं कर रही हूँ इस पे अब तक ये फॉलो ये किसको फॉलो करते हैं ये खुल ही नहीं रहा नेटवर्क ही नहीं
दिख रहा है
कैसे
बहुत पास है
I was trying